Okay, here's what it looks like on page 12. And I'm going to do, let's do number 2, okay? "46, 46 feet. This one's 42 feet. This one's 52 feet. And now we're going to go backwards. Okay. If you can use your imagination or look at your worksheet. Yeah. Okay. So you can see that this is a prism because it has this face and the back is going to look exactly like this, and it is parallel to each other and equal to each other. So what shape, since we're going to call this the base, what shape is this? It's a what?
Square.
This thing right here?
It's a triangle part. Is it triangle part?
It's a just this piece. I want to know what this shape is right here.
A base.
Rectangle.
It is, see, it has 4 sides. 1, 2, 3, 4. Okay. What did you say, Mary? Because you
Parallelogram?
almost. It could be a parallelogram, but these 2 sides are not parallel to each other. So it can't be a parallelogram. Kind of looks to me like a triangle with the top chopped off. So what did you say?
I said it was like, I don't remember.
Okay.
I said it's a triangle with the base of the triangle just with the top
Yes, I
out.
heard that, but it's not a complete triangle. Do you guys remember? No, it looks like this.
Which is a trapezoid.
Yes, it's a trapezoid. Can you see it now?
Yes.
The bases are parallel to each other. There's not one up there.
Oh, okay.
I was looking and I was like, why isn't there a trapezoid up there? Okay. The bases are parallel to each other. It's 4 sides, but the other sides aren't parallel to each other. That's why it's not a parallelogram. Okay, Mary? And if you drew this all the way up like this, it would be a triangle. Looks like a triangle with the top chopped off. It's a trapezoid. Trapezoid. Okay, so we will go back to what I want to do. I want to find the volume of this prism. It has 2 bases, so that makes it a prism. It is a trapezoidal prism. It's named for its base. Okay, and so volume, we know any kind of prism, any of them. This is the formula to find the volume of a prism. Now, what's the difference between the big B and the little b? Anybody?
I want to say that the big B is it's the base.
The base.
It's like the.
Yes, sort of.
It's more like basis.
Okay.
One base. One base. Right?
Okay, the B of the little b is a line that's the base, right?
Yeah.
The little b is the line that is the base. What is it?
The length of the base.
Okay, the little b is the lowercase one.
Base is the area.
Yes, yes. The capital B stands for the area of the base. It's the area of the base. 2 different things, the lowercase b and the uppercase or capital B. The capital B is the area of the base. And what's the little b for? Just the line that is the base. And you usually use that in the area formulas. Okay, so what you have to get used to is if you see a capital B, you're going to have to work this first and get a number. This is a problem in itself. You have to do this. So it says I have to find the area of the base. And then when I have an answer, I'll take it times the height of the prism. Okay, but for right now, I have to find the area of the base. So what we found out yesterday is it's much easier to find the area of something, of the base, if you draw it separately here. So I just pulled the base off. So I'm going to put my numbers on it. 46 feet. Here's 52 feet. This one is 42 feet. You see where I'm getting all these numbers? The 52 is this base. The 42 is that base. Trapezoid has two bases.
42.
The height is here. Remember, the height has to be perpendicular to the base, okay? So this is the height, which is 46 feet. So we have to find an answer to this first. So how do you find the area of this particular base? This base is a trapezoid. So go look at your formula chart and find how to find the area of a trapezoid.
Back to it's A
H,
parentheses, lowercase b plus lowercase b again.
B1 and B2. Okay, what it's telling you to do is that we have to add the two bases together. Now, the way you're going to know which ones are the bases, they're the ones that are parallel to each other. Okay? So these can't be bases to this trapezoid because they're not parallel to each other.
52 and 42.
Parallel, right? They go in the same direction, they're parallel. Okay. So these are the bases. Base 1 and base 2. Let me make sure I'm getting everything on the screen. Okay. So we're going to find the area of the base. Area equals 1/2. What's the height of this? This 46. And it crams together, so it is multiply.
Yeah.
Base 1 is 42 plus base 2, 52. Vanessa, we're on page 12 of that packet from yesterday, number 2. And then we're just going to work this out. So I have area equals 1/2 times 46 times 94. Okay, and when you do that in your calculator, you're going to have 23 times 94. Because I took 1/2 of 46, that's how I got 23. I did this first. Half of 46 is 20 times 94. I need somebody to do it.
I got 21.
1,162.
Yeah, I heard somebody. Hey, Zeus, did you already have it? Did I hear you talking?
No, ma'am.
I did 2,162.
2,162. Is that what you got?
Yeah.
Okay, so area equals 2,000.
Yes, ma'am.
Now, the problem is here that since this is an extra step, by the time you get through with this, it's possible you might forget what you're doing and put this down as an answer. And that's not an answer. Because that is the area of the base. It's the area of the base. To find the volume, I had to find the area of the base, put it into the formula. That was you, Isabel, that gave me the answer, right?
Yes, ma'am.
Okay, thank you. I didn't give you credit for that. Sorry.
Huh?
Okay. And then
Thank
this
you.
area of the base now is times whatever the height is. The height is the number or the line that's connecting the two bases. So what's the line, the length of the line that's connecting those two bases? And it's kind of hard with this trapezoid
31.
prism. Probably easier looking at it on the paper. And then, so again, we need to multiply, and Deborah can't do this in her head.
I got, I don't know if it's right, but 63, or 67,
67,
022.
2. And what do we put for units?
Squared. Oh, I'm in feet.
We
my
need
bad.
feet, and then volume is the little 3 that's cubed.
There. That's
Okay.
fine.
67022. Look on the back, see if that's the right answer. After we did all that. Yep.
67022.
It's exactly right.
Yes, that's correct.
Good, thank you, Isabel. Okay, this would be the volume. But what I will caution you about is when you're finding volume of a prism, you have to do this first. It's a problem by itself. And don't stop there. That's just the area of the base. Then you need to take it times the height of the prism. Is everybody okay with that?
I think so.
all the other pages, you should have information. You should know how to do them. But did anybody hit some snags or have anything marked that I can help you with?
No, I didn't start.
Not yet?
I'm just confused with half. We don't divide, right? We just, we divide.
Taking times 1/2 is the same as dividing by 2. So you could take 1/2 in your calculator and take it times, put this fraction in there and take it times this times that. Or you could take 46 times 94 and divide by 2. It means the same thing, multiply. So either way is fine. Actually, I was talking to Vanessa yesterday, and we learned the formula differently. Like for a triangle, this 1/2 base times height. Vanessa and I learned it as base times height and then divided by 2, which is exactly the same thing. You see? Because this 1/2, we just changed it to divide by 2. Now, the reason I don't use this one is because this one's the one on your formula chart. So on our trapezoid then, you can actually do this. Base 1, base 2 times height divided by 2. And that's the way I learned it also. You add the bases, take it times the height, and then divide everything by 2. But I want you to use the one that's on your formula chart because that's the one. But if you know that times 1/2 is the same as divide by 2, do it if it feels better. Okay, everybody fine?
Yes.
Okay, good. So, Naomi got to come today. Yay. Okay, so if you'll remember when I was talking to you about the difference between prisms and pyramids, We had prisms over here and they had two bases, right? Prisms have two bases. And then we had pyramids over here. It just has one base and a point at the top. Remember? Okay, we're going to go back and talk about prisms. That's what this handout's about. But I told you besides the prisms, then there is a rounded piece that is similar to the prisms. So the rounded one also has two bases. Hi, Naomi. Can she hear me yet? Hello, Naomi.
Hi, guys.
Hi. You guys want to say hi to Naomi?
Hi.
She hasn't been able to get on because she said her Wi-Fi is really bad out in the country. But she made it today. Yay.
Hey.
Okay. Now, today we're going to talk about finding the volume of a cylinder. Okay? Okay. So, guess what? It's like a prism. So, guess what? We get to use exactly the same formula.
And that's a cylinder?
Uh-huh. Now, the cylinder on your page might say volume equals pi r squared h. Does it say that? Or does it say this one? The volume for a cylinder. Yes, ma'am.
A cylinder is also a prism or just a 2D figure?
Is what just a prism? What?
Is a prism?
The cylinder?
Is also a prism?
No.
Or just a 3D figure?
It's just similar to a prism.
What is that?
No, the prism has to have the straight sides.
Oh, okay.
Okay, so this is similar and we work it the same way as a prism. No, you can't call this a prism because it doesn't have the straight sides. Okay, good question. Very good question. This one is called a cylinder.
Yeah.
But if you'll notice, it has two bases that are parallel to each other and they're the same size, right? So it's similar to a prism, only it has a circle. Okay, now, did y'all find the volume of a cylinder? This one? Yes. Okay, this one is the one on your formula chart. If you don't remember this one, for some reason, this part of the formula is how you find big B. So they're actually the same. But use the one that's on the formula chart, okay? Let me finish putting numbers on here. Okay, these will probably be the only numbers that you have on here. Now, we're going to have to remember, notice that the base is a circle, and what we've done up until now is just take the base out so we can look at what the base looks like. Here it kind of looks like an oval, but that's perspective. So this is actually what the bottom of this can looks like. All right? And then, so the measurement on here is 8 feet. That's this base right here. Okay? So we know that we have to find the area of the base, right? Okay, what's the area of a circle?
Is a area negative
Area equals
pi r2. The
r
radius.
squared.
Yeah.
R squared. Okay? Pi r squared. Here it is. This is the first part of the volume formula, is to find the area of the base. Now, what is R?
Radius.
Radius, okay? Can you tell me the definition of radius?
The circular. No, there's no
I didn't hear you. Okay. No, that's okay. You're saying it right. Tell me.
I can say,
No, you tell me in your own words, because you know, you started telling me.
it's the half of the diameter,
Diameter. Good. Okay, so it's the distance from the center of the circle to the outside, right? If we go all the way across through the center, it's a diameter, right? But the R in the formula is asking for the length of a segment that goes from the center to the outside of the circle. So the R in this case is 8, right? And it says to square 8 and take it to pi. Now, I'm going to look right here on your worksheets. Put this away. Okay, on your worksheets that you're going to be using today, it does say in the instructions to use 3.14 instead of your pi button. Okay, so for pi, because it says it in the instructions, we're going to use 3.14. That's an approximate evaluation for pi, but it says to use it in this case. 3.14. The decimal goes after the 3. Okay, so if you could tell me what that is. Like 25.52 or something like that. Area equals 3.14 times 8. Oh, no, it's not. We have to square the 8 first. Square the 8. That means 8 times 8 is 64. Then times 3.14. Okay, you have to do this first. Remember the please excuse my dear Aunt Sally, exponents come before multiplication. So tell me what 64 times 3.14 is. Do you see why it's 64? Okay.
100, because of the 2 is always 8 times 8.
192 and 1/4.
Times 4 is going to be 8 times 8 times 8 times 8.
Mm-hmm. Yeah, I was trying to figure out why she was doing so many 8s, but I had to think back what you said and you were correct. Okay, this is what we got. For pi, we're going to use 3.14. They're multiplied together, and R is 8. So we're taking 8 squared. 8 squared, when you square something, it means you take this times itself this many times. So it'll be 8 times 8. See what I'm saying now?
64.
Do 8 squared on your calculator. Just do 8 and yeah, now enter. 64. Okay, so this, we have to do exponents first. We have 64 times 3.14. That's going to be the area of the base, okay? And so what did y'all get?
I got like 200.
192.
You said what?
I got
192.
I got
192?
0.36.
Is it 192 point something?
I got 296.
Oh, 200.
200.96.
Do it here. 3.14 times 64, 200.96.
Oh,
200.
because they did 46 times 3.14. And they got 144.44.
Okay, so notice that, now I'm going to warn you, because what we did is just find the area of the base. We just found that. And on the test, they'll probably put this as one of the answers to see if you know how to finish this problem. So when we took the pi r squared that's given in your formula, that is the area of the base. So now this is 200.96. And then it says, see, we did the pi r squared. Now they said take it times the height of the cylinder. What's the height of the cylinder? 12. That's exactly right. Times 12.
Well,
And so our volume is going to be what?
24 or 2,400.
2,411.
Even point what? 52? Is what y'all got?
52.
I heard Isabel.
52.
Okay. And then what are our units? Feet what? Cubed. It's exactly right. Feet cubed. Because we found out yesterday that volume is three-dimensional. So we use the 3 and we call it cubed. Okay? Is everybody good? Let's do one more of those now that we don't spend so much time on it. Okay? And use this formula right here. Use the formula that's on your formula chart. Okay? Let me draw. I'm not even going to take it off of there. I'm just going to make one up. Okay? This will be a volume of the cylinder. And again, they're telling you to use 3.14 in place of pi. Those of you that haven't heard me much, if you get a problem on your test and they use pi, the special number pi, if they do not tell you in the instructions to use 3.14, then definitely use the pi button that's on your calculator because it gives a more exact answer. Everybody fine? I was kind of talking to them, sorry. Sometimes I don't know where to look. So always use the pi button unless they tell you in the instructions to do something else. All right? Because the pi is the most accurate. I'm going to have to quit in a minute. So let's do this. This is similar to what we had a Valero plant really close to where I lived. And the engineers there would have to deal with tubes and stuff that runs their chemicals and their different processes. And so they would actually use something like this, okay? So some of you always ask me, when am I ever going to use this? Well, engineers use it when they're trying to figure out how much pressure and everything is going to go through these tubes, okay? So here we go. Let's do this. That's 6 miles. "24 miles of tubing, 6 miles in diameter." Okay, I want you to find the volume, and our formula chart says pi r squared h is how you find the volume of a cylinder. Okay, so we need to start filling this out. We know that pi is 3.14 because they told us that in the instructions. So volume is going to equal 3.14 times, what's R? The radius. So what is it in this problem?
Radius for
3. And they will do that. They will make sure that you know what a radius is. See, this is going all the way across. That's the diameter. We need the radius for the problem. And so it's halfway across. So it's only going to be 3 squared times, what's the height of this cylinder?
24.
24, because it's just laying on its side.
24.
24. So if you're going to do your order of operations, we have to take care of this first. We have to take care of exponents. So now we have 3.14 times 9 times 24. Now it's okay if you multiply all the way across because it's just multiply now. Let me see.
So would it be the 260?
16.
Well, we're not
216.
going to use 3.14.
Okay.
Oh, 216 plus
Like 500 or
times.
something. Isabel, I think I heard you.
It's 216?
Just 16? No, it's going to be a lot more. Because 3 times 9 is
I
20.
got 600.
It's 24 times 9 times 3.
And I think I heard Naomi.
216.
Again, Naomi?
678.24.
That looks correct. And then our units,
Miles.
miles,
600.
and we're finding volume, miles cubed.
Times 9. 6, I mean.
Do y'all see? It's very important for you to remember the difference between diameter and radius, and you guys know it. That's not a problem, but recognizing it and not just putting numbers down. Okay, you've got to make sure that you use the radius, not the diameter in this volume. How are we doing? Are you ready to try some? And
Probably
then, I'm sorry?
So probably not.
And I know that you probably didn't finish the packet yesterday. However, Irene got through how many pages? You said like 7?
I had like 5 now.
Yeah, she did quite well before she left.
Good
So
job, Irene.
question?
I said, good job, Irene.
Okay, are there any questions from the remote students? Do y'all have questions? Jesus, are you there?
I don't.
Okay, that was Isabel telling me that she didn't have any questions. Is that correct?
Oh, well, I'm good.
Okay, I heard Jesus and I'm seeing Naomi
Correct.
shake her. So we're okay, all of us?
Yes, ma'am.
Let's go to work. You should have the first 13 pages that I sent you yesterday in this packet. I'm going to send you 3 more, so your total packet of this particular packet will have 16 pages in it, okay? Staple all of that together. I'm trying to keep the sections together.
Yes, ma'am.
Everybody fine? Okay, that's good. Okay, then I'm going to stop this recording and I will log out and see you guys tomorrow. How's that? So
Okay.
nice to see you guys. Yay. Okay, I'll see you tomorrow. I'll send your pages in just a minute.
Yes, ma'am.
You know I love you.
Bye.
Bye-bye.